Hello and welcome to the feedback video for assignment 7, Projectile Motion. In this video we're going to focus on the first 3 questions in the assignment, and at the end of the video you'll be asked to complete a question that includes some similar concepts. Please pause the video, attempt the question and hand it in to your teacher as soon as possible. The first question wants us to calculate the time of flight of a shot put fired from ground level and landing at ground level. In any projectile motion question, the horizontal component of the release velocity remains constant throughout the time of flight, and therefore a simple motion equation can be used to calculate the time taken. The tricky part is to calculate the horizontal component of the release velocity using trigonometry. Let's sketch a diagram and label the variables that are given in the question. To calculate the size of the horizontal component of the release velocity, we need to take cosine of 42 degrees and make it equal to the adjacent or horizontal velocity component divided by the hypotenuse, the release velocity of 13 meters per second. After a rearrangement of this equation, we can calculate a horizontal velocity component to be 9.66 meters per second. If you do not get this answer from your calculator, make sure it is in the correct mode. To calculate the time taken, we can rearrange speed equals distance over time and substitute our constant horizontal component velocity in to calculate a time of 1.77 seconds. Question 2 is a common explanation question in exam papers, first wanting you to identify the differences in the component velocities of a projectile object, and then to explain why there is a difference. It all comes down to Newton's laws, specifically his first, and that states that an object requires unbalanced forces or a resultant force in order to change its velocity. We know that for any projectile, it is said that the only force acting on the projectile object is gravity, and we know that gravity always acts vertically downwards. Here, I have marked on both the horizontal, or x, and the vertical y plane for a few instances along the parabolic path that the object takes. Here we can see that at each instant no external forces or component force of gravity acts in the horizontal plane. This means that the shot put's horizontal velocity remains constant. Vertical component velocity is different, as it has a force acting in the vertical plane. This force is the gravitational force of weight. It causes a constant acceleration towards the ground. That means when it is initially moving in an upward direction, its speed decreases before changing direction and accelerating down towards the ground. Even though it has changed direction, its acceleration was constant throughout. Question 3 wants you to state who wins and why. And it is only a straightforward question if you are able to imagine the path of both shot puts. Here we can see how the path of the shot put compares if thrown at the same time. Once you can imagine this, it is not too difficult to state that Valerie wins, and that the reason why she wins is that she released the shot put from a height above ground. But you would need to fully explain why that allows her to win, and that is that her shot is in the air for a longer time, and so can travel further with its constant horizontal component velocity. Right, okay, if you could pause the video, attempt the question and hand it in to your teacher as soon as possible.